electrophilic addition reaction. So addition of halogen to alkene, addition of halogen to alkene, addition of hydrogen halide to alkene, addition of X2 to alkene, addition of HX to alkene, addition of hypohalous acid HOX to alkene, addition of water to alkene, that is nothing but hydration of alkene, addition of hydrogen molecule, hydroboration oxidation reaction, oxymercuration demercuration reaction. Okay, I will explain one by one. In that first one is addition of halogen to alkene. Addition of halogen to alkene. First, to take this one. Right, addition of halogen to alkene. So I am taking alkene RCH double bond CH2. Okay, bromine, addition of halogen here. X2 gives rise to RCH double bond CH, X added to one carbon. This double bond become single bond. X added to here another carbon. Okay, that means addition of halogen is anti-addition. Addition of first point, addition of halogen to alkene, addition of halogen molecule to alkene is which addition? Anti-addition. Okay, so cisalkene plus syn addition, mesoproduct, and transalkene, some information, transalkene syn addition, active product, optically active product, formation of optical active product formation takes place. And cisalkene, for cisalkene anti-addition, optical active product. For transalkene, anti-addition, mesoproduct formation, optical inactive. Mesoproducts are optical inactive. So okay, this is some information. If they ask a question, cis, alkene is cis. We know halogen addition is anti. Cis alkene anti, optical active. Cisalkene, if it is trans, anti, meso. So if alkene is cis, syn addition meso. If alkene is trans, syn addition give optical active. If alkene is cis, anti-addition give optical active. Alkene is trans, anti-addition. Halogen is always anti-addition. Okay, so if alkene is trans, anti-addition give mesoproduct, optical inactive. Mesoproducts are optical inactive. Note that meso compound already explained in isomerism topic. Meso compounds are optical active. Meso compounds are optical Meso compounds are optical inactive. Okay, so take this information, I will explain. Let's see here. RCH double bond CH2 addition of X2 gives rise to RCH double bond becomes single bond CH2, here X is added, here X is added, that is the product. Where X is what? Where X2 is chlorine, bromine or iodine. Chlorine or bromine. So in case of iodine, RCH double bond CH2 plus I2, what happens? Here reversible reaction takes place, not this reaction, irreversible, this is reversible reaction. So in case of iodine, reversible reaction takes place. RCH single bond CH2 I and I, this is unstable, that's why unstable, that's why reaction is reversed, reversible reaction. In case of iodine, reaction is reversible. If it is chlorine or bromine, reaction is irreversible in nature. Irreversible. Okay. So this addition of, especially addition of bromine to alkene used as a test for unsaturation. So addition of bromine to alkene, especially 5% bromine in carbon tetrachloride. Addition of bromine to alkene used as a test for presence of unsaturation. Because if unsaturation is present, bromine addition takes place, transition takes place, bromine addition takes place, bromine color disappears. Bromine has brown in color. So if some substrate 5% bromine in carbon tetrachloride is added, if its bromine brown color disappear, the substrate must be alkene. Thus we identify the unsaturation in alkenes, presence of unsaturation in alkenes. So what is test? Upon addition of what is test here? Upon addition of bromine to alkene, if brown color of bromine disappear rapidly, brown color of bromine disappears it indicate presence of unsaturation. It indicate presence of unsaturation. Thus unsaturation can be identified with the help of bromine. Okay, bromine has brown in color. We usually take 5% bromine in carbon tetrachloride, brown in color. If it is added to alkene, then if alkene or anything, we are going to test that. If 5% bromine in carbon tetrachloride is added to some substrate, if that substrate disappears, decolorize with bromine, the substrate must be alkene. Unsaturation is there. Otherwise, there is no unsaturation. Thus, the addition of bromine to alkene serve as a test for identification of double bond. That is my point. Okay. Next thing, this reaction takes place in 2 steps. As we learn, electrophilic addition reaction takes place in 2 steps. Addition of bromine, addition of chlorine also takes place in 2 steps. So first, this is some alkene. Okay, next addition of bromine. So here alkene is what? Substrate, and here bromine is what? Reagent, attacking reagent. Okay, this reaction takes place in presence of usually carbon tetrachloride. Okay, so carbon tetrachloride. If this attack here and this bond is heterolytic bond fission, because this electron taken by this carbon. Okay, here what? In substrate electromeric effect, positive electromeric effect, here heterolytic bond fission. That gives what? That gives here what is added? Here bromine is added, here 2 bonds same as usual, here double bond becomes single bond, here what? This carbon become positive. That carbon become positive. Due to loss of electron, that carbon become positive. And you know, here lone pair electrons are present. That form a. This is carbocation. First step, carbocation. Carbocation is formed, but which is readily attacked by bromine to form bromine carrying positive charge, cyclic bromonium ion. Cyclic bromonium ion. This is step 1. In step 2, next what happens? Another bromine. Here this bromine become positive, this bromine become negative. Addition of that bromine takes place. Addition of Br minus from opposite side. So if it takes electron like this added from downside, then it gives what? Here bromine comes to first carbon, that become neutral. Okay, here bromine addition takes place. This is product, addition product. Okay, if this cyclic bromonium formation not takes place, then carbocation can undergo rearrangement. Due to formation of the cyclic bromonium ion, there is no chance for this carbocation to rearrange. That is my point. So due to formation of cyclic bromonium ion, due to formation of cyclic bromonium ion, carbocation rearrangement is not possible. Okay, what is the rearrangement of carbocation? We already discussed in reaction intermediates topic. Here also it will come. Okay, how in which there are 6 examples of electrophilic addition reactions. You know, in those some reaction carbocation rearrangement they involves. Here addition of bromine to alkene do not involve rearrangement of carbocation. Why addition of bromine to alkene doesn't involve rearrangement of carbocation? Due to formation of the cyclic bromonium ion. Okay, right. Take this one about addition of bromine to alkene. What are important points? So bromine to alkene, chlorine to alkene is irreversible reaction, but iodine to alkene is reversible reaction because vicinal diiodide product on 1,2 carbon iodine is attached. So vicinal diiodides. vicinal diiodides are unstable. That's why addition of iodine to alkene is a reversible reaction. Point number 1. Next, addition of bromine to alkene serve as a test for identification of unsaturation in alkene. Usually we take 5% bromine in carbon tetrachloride solution that has brown in color. If our substrate disappear, the brown color of bromine substrate must be with unsaturation. If substrate doesn't decolorizes bromine, then substrate may not contain unsaturation. Thus, addition of bromine to alkene act as a test, serve as a test, used as a test for identification of unsaturation in alkenes. Next, third point, due to formation of the cyclic bromonium ion, carbocation rearrangement is not possible. Of course, intermediate is carbocation, but carbocation rearrangement is not possible. In other cases, if carbocation is intermediate, that rearranges. Some unstable carbocation rearranges to more stable. If it is primary, there is a chance it becomes secondary. If there is a chance it becomes tertiary. If ring expansion takes place, ring compression takes place, thus unstable carbocation rearranges to stable carbocation. But here that rearrangement is not possible because cyclic bromonium ion formation takes place very rapidly. Okay, so this is about what? Addition of bromine to alkene. Next, addition of hydrogen halide to alkene. That is very important. So where Markovnikov rule involves, so take this one. Right, next, addition of hydrogen halide to alkene. Addition of hydrogen halide to alkene. This is very, very important. Okay, right. See, I am taking some alkene, addition of HX. Here solvent is neutral nonpolar solvent like CCl4. Neutral nonpolar solvent. Neutral nonpolar solvents are required here. So in reaction mechanism part 1, I have explained types of solvents there. Okay, then what happened? To one carbon hydrogen addition takes place, to another carbon halogen addition takes place. Okay, the halo compounds are formed. Addition of hydrogen halide, first important point, addition of hydrogen halide to alkene is anti-addition, trans-addition, anti-addition, opposite side, anti-addition. That means we should not write like this, we have to write like this, anti-addition. Okay, opposite side addition. Point number 1. For example, what is HX? Where HX is HCl, HBr or HI. Reactivity of hydrogen halide. So which one is more reactive? HI is more reactive than HBr. HBr is more reactive than HCl. This is strongly acidic in nature, more reactive. Okay, HI is more reactive. So if it is unsymmetrical alkene, here both carbons are same, this is what? Symmetrical alkene. Symmetrical alkene means on double bond both equal distribution on both sides. On carbon-carbon double bond, two sides are same. That is what? Symmetrical alkene. For symmetrical alkene, there is no confusion, there is no rule, because so to this carbon hydrogen, this carbon halogen, or maybe to this carbon halogen, this carbon hydrogen, both become same, it doesn't make any difference. But in case of unsymmetrical alkene, in case of unsymmetrical alkene, addition reaction takes place according to Markovnikov's rule. Markovnikov's rule. See here, if alkene is like this, both carbons are not same, electronic environment on both carbon not same, all the chemical reaction mechanism about of electronic environment only. Okay, here this carbon not same. Here two hydrogens are neutral. Here this carbon contain one hydrogen, one is what? Alkyl group plus I group. Plus I group push electron towards this carbon. That means the electronic environment on these two carbon not same. That's why addition of HBr takes place or HX takes place according to Markovnikov's rule. So according to Markovnikov's rule, what here? Here H added to only this carbon, H added to this carbon, and X added to this carbon. Thus what is product? RCH, here X CH3, this is major product according to Markovnikov. So one more product also formed, that is RCH2CH2X, but this is very minor. This will explained by Markovnikov's rule. So addition of hydrogen halide to alkene takes place normal. Addition of hydrogen to alkene takes place normal. To one carbon hydrogen is added, to other carbon halogen is added. There is no confusion. But if both unsaturated carbon atoms are not same, if both double bonded carbon atoms are not same, then hydrogen particularly adds to this carbon and halogen adds to this carbon, that is the major product. If hydrogen added to this carbon, halogen added to this carbon, that is very, very minor product. So how this reaction takes place like this? This could explained by Markovnikov's rule. So first to take this one, I will explain Markovnikov's rule. Right, what is Markovnikov's rule? Addition of hydrogen halide to unsymmetrical alkene takes place in such a way that, in what way the reaction of addition of hydrogen halide to alkene takes place? Positive part of reagent added to double bonded carbon, unsaturated carbon containing more hydrogen. Positive part added to unsaturated carbon containing more hydrogen. That means negative part added to unsaturated carbon containing less number of hydrogen. That is Markovnikov's rule. So already reaction I have written. That is what? RCH double bond CH2. This is what? Unsymmetrical alkene. Unsymmetrical alkene, because both carbons are not same. So now addition of hydrogen bromide. Example I am taking addition of hydrogen bromide. Here what is the positive part? This hydrogen is positive, because between hydrogen and bromine, bromine is more electronegative, that become negative, and hydrogen is positive. Okay, so the positive part mean hydrogen only. Positive part of reagent attached to double bonded carbon, that means these two carbon, double bonded carbon containing more number of hydrogen, that means this added here and bromine automatically added here. So RCH, here bromine is added. Okay, double bond becomes single bond. This CH2, here hydrogen added, so CH2 becomes CH3. That is major product. Of course, another product is also formed, that is CH2Br. Br, this is minor. Anti-Markovnikov product also results minor. Markovnikov product, anti-Markovnikov product. You know Markovnikov product, Markovnikov's rule based on Markovnikov's rule based on stability of carbocation. He explained on he proposed rule on the basis of stability of carbocation. Explained on the basis of stability of carbocation. Okay, see here. So in this reaction, first RCH double bond CH2, here first addition of H plus takes place. Then two possibilities. So if step 1 like this, H plus added here. So that is first possibility, green possibility. I will give this possibility with green color. Okay. What is second possibility? Second possibility is this may be shifted here and hydrogen added here. So that is second possibility. Second possibility is like this. So due to first possibility, what happened? This pi bond shift towards this carbon and hydrogen added here. Then this pi bond shift towards this carbon means this carbon lost pi bond, so this become positive. Or CH, here what we get? Positive charge, and here what? CH3. Okay, that is possibility. Or otherwise I will write with green. Okay, here R, here CH, positive charge, and this become like this. Second possibility, of course this is according to Markovnikov's rule. Why not this? I am explaining why not this. Okay, so if this pi bond shift towards this carbon, H added here, pi bond shift towards this carbon become positive. That means R here CH2 and this carbon become positive, because here pi bond shifted here means this carbon become positive. So this is major, this is more stable, this is major, that's why this product is major. Of course, by the addition of Br minus. Next step, Br minus addition. So what is the next step? Addition of Br minus. So in step 1, H plus is added. In second step, Br minus. So that what is RCH? Here what is added? Br and CH3. So what I am saying, this is major product. This is what? Major product. So if it is formed Br minus addition or CH2 and CH2, here bromine addition takes place. What I am saying, this is minor. So according to Markovnikov's rule, this is major, this is minor. Why this is major? Because this is what? Secondary carbocation. And this is what? Primary carbocation. This carbon directly attached with only one carbon. This carbon attached with two carbon. This is alkyl group. In alkyl group, central atom is carbon. In alkyl group, central atom carbon. So carbon here, two carbons, so secondary carbon. Here this is directly attached with only one carbon, so that is what? Primary carbocation. This is what? More stable. This is what? More stable. More stable intermediate, major product. This is less stable. So this is minor product. Why is primary carbocation less stable? Based on inductive effect. Only plus I group present on one side. Here plus I group present on both sides. Plus I group, electron donating group, increases stability of carbocation. Tertiary carbocations more stable than secondary carbocation. Secondary carbocation more stable than primary carbocation. That's why this is the more stable reaction intermediate formed. That's why the product formed as per that is major. This is less stable, that's why this is formed in lesser extent, its product is minor. Thus Markovnikov explained on the basis of stability of carbocation. So here if you see here, what is the product here? Hydrogen added to double bonded carbon containing more hydrogen, green. Hydrogen added to double bonded carbon containing more hydrogen. So this is Markovnikov product, this is anti-Markovnikov's product. So this is what Markovnikov's and this is what anti-Markovnikov's rule. This is what anti-Markovnikov's anti-Markovnikov product. So thus Markovnikov explained formation of major product in the reaction addition of hydrogen halide to unsymmetrical alkene. Take this one. Vinyl chlorides, CH2 double bond CHCl, vinyl chloride, when treated with HCl, it gives. This reaction takes place according to Markovnikov's rule. Markovnikov's rules means the positive part this one, negative part this one, positive part attached to double bonded carbon containing more hydrogen. So CH2 becomes CH3, double bond becomes single bond, CH, here what Cl, this is Cl. This is what ethylidene chloride. Ethylidene chloride. This is what Markovnikov's rule. Okay, so take this one. Right, major product of this reaction is, so among these four, which is correct option? So how do we do that? This is reactant in HI addition reaction. First electrophilic addition reaction. So in electrophilic addition reaction, first H plus ion attack takes place. If H plus ion added here, this become positive, secondary carbon. If H plus ion added here, this become positive, tertiary carbocation. So which is favorable? If H plus addition takes place here, this become positive, that is the tertiary, that is more stable. If H plus addition takes place here, this become positive, that is what? Secondary. So compared to secondary, tertiary carbocation is more stable. So here addition of hydrogen takes place, no need to write hydrogen. Here what? CH3, and this is what? Positive, tertiary carbocation. Now addition of what? I minus. First H plus addition followed by I minus addition. So I minus addition takes place like this, that gives here what? CH3 and here I. Which option is correct? Option A is correct. Take this one. Next, see this question. Reactivity order of the following towards electrophilic addition reaction. So to add electrophile, the reactant, the substrate must be nucleophilic in nature, more electron dense in nature. What is electrophile? Electrophile is electron deficient. To add electron deficient, this is what? This is reagent. Electrophile is attacking reagent. To add that reagent, substrate must be electron rich. So now which one of the following substrate is more electron rich? Here all the ring is same, only at this point this is different. At that point that is different. So what is present there? There is nothing, mean hydrogen is there. Okay, that is 1 into methoxy group is there. What about methoxy group? Methoxy group is plus M group, positive mesomeric group. Methoxy group is positive mesomeric group. So electron donating group, then electron density increases, more reactive. It is more at this point, at this center. Electrophilic addition reaction takes place. To that center, it is donating electron. That means here electron density increases. Electrophile readily attack. Electron rich mean as electron density increases, electrophilic attack readily takes place. If you see third example, chlorine is there. So chlorine, of course chlorine contain lone pair. Okay, in this way positive mesomeric effect is possible. So as more electronegative, chlorine more electronegative than carbon, minus I effect is also possible. Both are possible for halogen. But in other cases, mesomeric effect dominate over inductive effect. But only halogen, for halogen, inductive effect dominated over mesomeric effect. That's why, so this act as minus I group, rather plus M group. Okay. Next, methyl group. If methyl group is present there, so what about methyl group? Methyl group is plus I group. So now which one is more electron rich? 2 is more electron rich, first of all. First 2, then electron withdrawing, neutral, electron releasing. 4 is more, then compared to minus I group, neutral is better. So 1 followed by 3. 2, 4, 1, 3. 2, 4, 1, 3. Yes, this is correct. Take this one. Next, see these questions. Here, addition of HCl in non-polar solvent. So here, what about H plus? H plus is what? H plus is positive part. This positive part attached to double bonded carbon containing more hydrogen, and halogen, that means chlorine attached there. So product is CH3. Here chlorine added. Here chlorine added. Here CH2 becomes CH3. That is the product. Here positive part, this one attached here, then to this part bromine attached. So product will be CH3. This is, and this is what? Br. Already we have written in the last example where HI, here HBr. That is the difference. For this reaction, so H plus added here, bromine added here. If you write like this, CH3, if bromine added here, this become Br and this becomes CH3, but this product is wrong. Why is wrong? Carbocation rearrangement possible. In addition of HX to alkene, HX, HBr, HCl, HX addition, intermediate is carbocation, rearrangement is possible, reaction takes place according to Markovnikov's rule. Okay, I will give all reactions in a tabular form. So first see this. Why this is wrong? First of all, in CH3, CH3, yes, CH double bond CH2, addition, electrophilic addition, reaction initiated by addition of electrophile added here, because this carbon takes electron, this carbon become positive. So what is that? CH3, okay, here CH, and this is what? CH plus, and this is what? CH3. Okay, right. So here this is what? Secondary carbocation. If hydrogen transfer takes place here, 1,2 shift. So otherwise write this hydrogen separately so that you understand clearly. Okay, here this hydrogen transfer takes place. 1, 2 hydrogen shift, H minus shift. It is not tautomerism. In tautomerism, H plus. This is what H minus shift. Rearrangement. What we call carbocation rearrangement takes place. Carbocation rearrangement. Carbocation rearrangement. Then what will be the intermediate? Tertiary carbocation is intermediate here. So here H along with bond pair moved here, CH become CH2 and CH3. This is about what? Secondary carbocation. Secondary carbocation. Compared to secondary carbocation, tertiary carbocation is more stable. Secondary carbocation. And this is what? Tertiary carbocation. Tertiary carbocation is more stable. Now addition of bromine takes place. So reaction always proceed through more stable intermediate. The product is like this. Product is like this. So this is product. This is not. This is wrong. Okay. So this is what? Wrong product. That means rearrangement of carbocation involved here. That is my point. So at the same time, you have to verify for addition of hydrogen bromide in Markovnikov's rule, and intermediate rearrangement is also. Both are involved here. So verify. Take this. Right. Next, see this reaction here. If you see mechanism, first addition of, sometimes they will give thick line wedge dash formula. First addition of H plus here. H plus addition give two types of, both two possibilities. What are two possibilities? H plus addition may takes place here, or H plus addition may takes place here. Both possibilities. So if H plus addition takes place, here, then what will be product? What will be intermediate? H plus addition takes place here means this carbon takes electron, this become positive. This carbon takes bond pair and given to this H plus. This carbon takes pi electron means this carbon become positive. This is positive and here hydrogen is added. Next here what? CH3. Hydrogen added here and this carbon become positive. Now second possibility, if H plus addition takes place here, pi bond shift here, H plus addition takes place, this carbon become positive. Now these two are same in some aspects. What are they? So here this is which carbocation? Secondary carbocation. Secondary carbocation. And for this, this is stabilized by inductive effect. Two inductive effect groups are there. Both are same. Secondary carbocation. And how many alpha hydrogen here? 2 alpha. For this one, this is alpha carbon. For this one, this is also alpha carbon. How many alpha hydrogen? 4 alpha hydrogen. 4 alpha hydrogen mean hyperconjugation also same. Secondary carbocation, inductive effect same, hyperconjugation same. Okay. For both same. I am talking about here and here same. Here this is also secondary carbocation or not? Okay, secondary carbocation. Secondary carbocation. Secondary carbocation. For this one also how many alpha hydrogen? So for this one, this is alpha carbon, this is alpha carbon. Alpha carbon, alpha carbon. 2 bonds there mean 2 hydrogen. Here 2 bonds there mean 2 hydrogen. 4 alpha hydrogen. 4 alpha hydrogen. Here how many alpha carbon? So that means both are secondary carbocations, and on the basis of hyperconjugation also same. Then what will be the product in above reaction? We can expect two products. What is that? If H plus formation take carbocation formation takes place at this carbon, here this carbon getting bromine and this is CH3. Here by the addition of bromine, by the addition of Br minus, here Br minus addition takes place. If Br minus addition takes place, this is the, here Br minus added, two products. Now what I am saying, this is the major product, this is minor product. So what is major product? Major product always formed on the basis of stability of carbocation. Here both carbocations are same. Secondary carbocation, both are same. 4 alpha hydrogen, that means hyperconjugation also gives same stability to these. Now, how can I say this is the major product? How can I say this is the major product? Because inductive effect is, this is more stable compared to this one. This is more stable. Both are secondary carbocation, but this is more stable and this is less stable. Carbocation stability factors are same here. Both are secondary carbocation. Both have 4 alpha hydrogen. Hyperconjugation effect also same, even though this is more stable. Why? That is my point. This is answer because reason for this one. Why? Here inductive effect is, generally inductive effect depends on distance. Inductive effect depends on what? Distance. As carbon chain distance increases, distance So here this is what? This is plus I group. Methyl group is plus I group. Methyl group is plus I group. Plus I groups increases stability. Plus I group increases stability of carbocation. Plus I group increases stability of carbocation. So both have plus I groups. Here this is plus I group and this is also plus I group. Plus I group here, plus I group here. But where distance is less? Distance is less here. So as the distance increases, plus I effect increases along carbon chain. As the distance increases, plus I effect inversely proportional to what? Distance. As the distance increases, I effect decreases. As the distance increases, here this is positive, here this is positive, here more distance. As the distance increases, here electrons comes like this. Here electrons have to travel like only this distance. As the distance decreases, inductive effect increases, stability increases. That's why this is more stable. Whenever this is more stable, its corresponding product will be major. That is my point. Take this one. This is important example. Take this one.